Hello friends, welcome back to my YouTube channel Infinite Knowledge, and we are back with another great project, and in which we are synchronize our generator with the grid. So you can see this is our generator part. This is the power plant. You can see it is the entire power plant which are going to synchronize with the grid. And what are the technique that we have to check before the synchronization that will cover in this video. So stay tuned with us. So you can see here. Uh, this is a generator in which I have used a diesel generator. Diesel generator is connected with the alternator, and alternator generate the voltage. Here I have 405 voltage for sake of simplicity. Then it is connected with the entire grid, and you can see this is the grid. In grid, for the grid I have used a swing generator. So swing generator treated as a grid. Okay. So yes. Mm, Here we are measuring what we need to check before the synchronization. Before the synchronization, you have to check whether the voltages are okay or not. We have taken two inputs. One is voltage from grid, another is voltage from generator. The generator means the power plant generator. For sake of simplicity, I have considered one generator. But in power plant, that may be more than one generator also that are running parallelly. Then we need to frequency. We need to check the frequency from generator, frequency from the grid. Then phase angle. Phase angle is also very much important before the synchronization, and this is a RYB phase sequence. If all the things are okay, then and then our breaker must be closed, and then breaker will be closed, and it will going to synchronize with the grid supply. Okay, and this is a protection. I have already uploaded one separate video for the protection, and for the protection you can see different protection has been covered. One is overcurrent protection and short circuit protection. The ANSI code is 50 and 51. Then voltage protection. Voltage generated by the generator must be within limit. The frequency of the generator must be within limit. Then excitation that we are providing to the generator must be limit. And the reverse power protection. It means generator is not working as a motor. All type of basic protection that we have used in power plant has been covered here. Okay, so I just wanted to give you some basic understanding of the synchronization. So this is the black line which is known as a grid supply. This is dotted line which is generated by our generator. So you can see there is slight difference. So this difference is known as a voltage phase angle, and the amplitude, voltage amplitude is this much, or you can say magnitude or amplitude. This is the amplitude from this point to this point. Okay, and what is the frequency? Frequency of system and frequency of generator. You can see this is the frequency of grid and frequency of the generator. So before you synchronize your generator, this type of variation may be there. Variation in the phase angle, variation in the voltage, and variation in the frequency. So that you have to understand before you synchronize. So that we have already covered. So I have already run the model because it takes too much time to run. And for sake of simplicity, you can see here voltage of grid and voltage of generator. So if you want, you can get. Okay. So initially, you can see before the synchronization happen, there is slight difference between the voltage and voltage of generator and voltage of grid. So the blue line is treated as the voltage of grid, whereas yellow line is treated as a voltage generated by generator. And there is slight variation, very less than a one even. It's just 0.01, I can say. This is a point and this is another point, so I can say this is 0.0001 difference is there. So we are very nearer to our supply voltage, and at that condition which is very satisfactory uh, to synchronize, and at this condition we have synchronized. So finally only one signal is there and both the voltage are overlap each other. So yes, what is the condition of the voltage angle, phase angle? It will be less than 1, and we are 0.001. We are very good condition. And this is a frequency. We are also frequency must be in the range of plus or minus 0.5, and voltage must be in the range of plus or minus 1%, 1 to 2%. Okay. Okay. So yes, actually we have designed for the 450. So 1 to 2 voltages may be 80, you can say 80 or 60. So just for simplicity, I can change it to the plus 60 to minus 60. 1 or 2 percentage is enough because we are on the 415. So if all the conditions are okay, then and then breaker must be closed. And once the breaker is closed, there is always some hunting. You can see after synchronization, we are get slight variation in the current for only 3 seconds, very short amount of time, and then current is constant. So if you want, you can check the RMS value as well. You can see how efficiently initially there is slide hunting because at this condition we have synchronized our breaker and initial peak. Then I can say all the generators facing slide variations, slide oscillation after the synchronization nearly 6 to 7 seconds it's come to the stable condition. Then current is totally stable. And same effect on the grid side because it's effect on the grid as well. So if you want to check the current, you can see at this condition also slight variation initially and then it is a totally stable. Okay, and the 47 ampere is right now provided by the grid, and I can say 165 ampere provided by the load, and this is the final load is taking this much amount of energy. Okay, so if you want to check the waveforms of the load, because current taking by load is as per its load requirement. Okay, so waveform is very clear, and there may be a slight current more than the load because of the circulation current. There is slight circulating current between the grid and between the generator. And if you want to check power, you can check from here. Okay, so this is the power from grid, power active power from grid, reactive power from grid. So initially there is a zero. At this condition we have synchronized. So as synchronized, generator taking reactive power and feeding reactive active power, feeding active power, taking reactive power. So as it is feeding the feeding active power, this grid power is reduced, and it is taking active power, reactive power. This grid reactive power is increased. Okay, so the power must be balanced in the system. If someone is feeding, someone is taking, and if someone is taking, another one is feeding, same to same. Okay, or vice versa. So yes, these two are, first is active power from the grid. This one is reactive power. Second one is reactive power from the grid. Third one is active power from the generator, and fourth one is reactive power from the generator. So this is how it is balanced. And once it is balanced, all the systems are stabilized. So yes, I have already run the model, and that's why you are not aware about of what I have done. So I just restart the model and check what is happening. Before it, you can see the speed is also constant, 3000 RPM of the generator. Initially there is slide variation and then it is stabilized, and that's why we are getting stable frequency. Okay, let's say I want to run the model again and I want to synchronize the generator with the grid again. If I start the simulation, yes, it takes some time, and we need to, okay, we need to stop this breaker. Okay, you need to run. Before you run the model, make sure the switch is off, the final synchronize. If you just on this switch, synchronization match, then it will generate the start command to the system. Okay, so I just turn off the switch. This is the final synchronization which directly synchronize with the grid. They directly synchronize our power station with the grid. So yes, I just stop, I just turn off this breaker by turning off this switch. So you can see there is no ampere. This light ampere which is minus 10 raised to 19, which is not ampere, this is internal gauge. Okay, so generator is working perfectly and it is generating this much amount of voltage. And make sure before you are uh, turning on this breaker, make sure your voltages are nearer to the grid supply or slightly higher to the grid supply. Okay, so right now I can say which is we have very nearer voltage to the grid supply, so I can start the, or I can synchronize with the grid. So you can see this is the ampere that is taken by the load, and this is the ampere that is feeding by the grid. Okay, and we need to check all the situation. If everything is 1, then it is okay, and if it is 1, we can just press the generator synchronization. Okay, this is 1, and if it is 1, then I can press this switch. As I press the switch, you can see that our system, our generator is synchronized with the grid. This entire grid, this is a national grid, you can say it is a national grid, and this is your power station, and that you are connected. Yes, obviously voltage levels are not there, voltage levels are not match right, but this is how the system is working. You can just use a transformer to step up and step down, you can do it over here, but our main concern is check this voltage, frequency and current and synchronize satisfactorily. So yes, initially there is slight variation. I recently synchronized the breaker, so you can see it will increase and then it takes some time to decrease. Okay, so we are just at 0.2 level, and if you want exact simulation, you need to run this simulation for 5 to 6 seconds at least, or if it may take half an hour or might be 1 hour, but you will check exact waveform that I have earlier explained. Okay, so this is how the generator station are working, and this is how the power plant are synchronized with the grid nationally. And yes, this is a protection circuit. Obviously, is there any abnormality, then it will detect and it will isolate this breaker. The breaker which is recently connected, directly connected at the terminal of the generator, and which totally isolated the generator from our grid or even a dummy load. Okay, what is a dummy load? Dummy load is the auxiliary load. When you are running the power plant, to run the power plant own itself requires some power source. So that is known as a dummy load or critical load, I can say, and that may be a 10 to 12 percentage of the entire generation, or depend on the size of the power plant. Okay. So yes, this is from my side. Thank you very much for watching this video. If you have still any query, just comment it. I will definitely reply. If you want this model, you can connect with me through my email ID given in the description box, or my WhatsApp ID. It is also given in the description. For any type of MATLAB project, electronics or electrical project, you can connect with. Thank you. Thank you very much.